something.
15 minutes, I don't want to learn something.
I just learned the new rules.
That's gonna get us like 1% through the lesson.
Yeah.
Okay, so 3.1, functions. Functions, this is our title. So we've got a couple of things I want to define here, some vocabulary. And the first thing is a relation. A relation is a set of ordered pairs. A set of ordered pairs. So any set of ordered pairs constitutes as a relation. This is more of like the square versus rectangle idea. Okay, a relation would be the overarching umbrella word. All rectangles have four sides, right? But a function is a specific type of relation. Okay, so we'll look at that in just a second. I got pencil and paper. Aren't you so excited? Listen, we have an Algebra 2 class that's not honors, and they're not as crazy as I am. So if you would like to just do Algebra 2 regular, that's an option. But if you want to stick it out in here, you're welcome to be here.
Why does he get the option?
Because I don't know this guy.
You took this class like way before.
I didn't know what it was gonna take.
I think everybody warned
My
us.
grandma told me to take this class and wouldn't let me get out.
I love your grandma. She's wonderful. All right, so the next piece we're going to talk about here is the domain. The domain. Anybody heard this word before? Yeah, you better have, because you just came out of Algebra 1, and that's huge. All x values, right?
I didn't learn
The set of all x values. The set of all x values, the domain. The domain. If I'm looking at a graph, I measure how far left to right. How far left to right does this function stretch? What are all the values to the left and all the values to the right that might be covered here? Okay. What's the other word? Range. So if the domain is the set of all x values, then the range is going to be what? The set of all y values. Set of all y values. And so that's going to measure always from the bottom of the graph to the top. Bottom to top. Anytime we're measuring domain and range, we always do least to greatest. Always, always, always on these two options, we measure from least to greatest. Okay. Least to greatest. So we've got the set of all x values, the set of all y values. What's another name for domain besides x? Anybody? What's another name for domain besides the set of all x values? X. What else could I call it? Let's put a table, a T-chart. Write a T-chart on your paper. And in one column, you've got X, and in the other column, you've got Y. And under X, let's put the word domain, because we just said domain tells me all the X values that it may be in a relation. And under Y, let's put range. That's all the Y values that may be in a relation. Anybody got another name for these two? Domain, range. What types of variables are they? You ever heard of variables? Which one's which? What kinds of variables do you have? Two kinds. The blank variable and the other blank variable.
You might as well tell us. No, it's not.
Y'all are in chemistry, yeah? How about independent and dependent? They really do know things. They're faking for you. They know things, though. Independent variable and dependent variable. Okay, so X is going to be independent. It's the one that doesn't care, right? X is the independent variable. It stands alone. X can be anything. But depending on what I put in for X, my Y value may change, right? So my Y value is dependent on whatever value I have for X. Whatever value I input for X will determine the output Y. Okay, so there's the other two words that we see all the time. For X, we're going to call it input. This is the value that I put in or plug in. Here in Texas, a lot of times we say, I'm going to plug it in. We plug in the number for X. That determines what number we output for Y. Okay, so outside of Y, we're going to have the word output. Input, output. So these are the three main words that we see for X and Y. Okay, if I say, what are your input variables? You're going to go read all of the little X ones. If I say, what's the output of this function? That's all the Y ones. What's the domain of this function? X, left to right. What's the range? Y, bottom to top. Okay. One way that I used to teach this when I taught Algebra 1 is I told them if the word itself has the letters IN, those are all the X ones. Any of the words that have IN, those are your X words. Input, independent, domain. Okay. All right. So that's as far as I've got with domain, range, input, output. Do we want to do the mapping part right now? Maybe? Yes. We're going to cover the mapping part, and then we'll take tomorrow and finish. Y'all are...
Like, we started, like, this week off that, and next week it's only 4 days, so maybe we should take...
Next week's only-
We should take 2 weeks, right?
Not doing...
Because we can't do anything on a 4-day week with a snow day, half day.
Yeah,
And then next week's already messed up because of Monday's off. So we should wait until 3 weeks from now, and then we should learn math. Is that what we're saying?
Whoa. Monday's off.
Yeah, Monday you don't have school. Apparently it is. Apparently it is Martin Luther King Day. Okay, so a function f. Here's what a function is. So we wrote down that a relation is the set of all ordered pairs. Just any old set of ordered pairs. A function is a special type of relation, like a square is a special type of rectangle. Okay? A function is a relation that assigns, we use the letter F to talk about a function. A function F is a relation that assigns a single value in the range, to each value in the domain. That assigns a single value in the range to each value in the domain. So there are lots of different ways that people say this. When I taught Algebra 1, I would say for every input, there's exactly one output. Have you heard that before? Yeah. For every input, there is only one output. Another way to say it is no x values repeat. No x values repeat. That's when I know I'm looking at a function. If you wanted to write those two things down, and that was for every input, there is exactly one output. And the last thing that I told you was no x values repeat. No x values repeat. Okay, so for every input, there's exactly one output. No x values repeat. Cool beans? Yeah? Okay. So then the textbook goes through this mapping business, and they give me two bubbles. And in the left side of the bubble, I've got the letters P and Q and R. And in the right side of the bubble, I've got M and N. And the arrows map P to M. So if P is the input, M is the output. Everybody's seen this mapping diagram before? If Q is the input, N is the output. And if R is the input, N is also the output. Is it a function? For every input value, there is exactly one output value. Is it true? Yes. For every one input value, so where does Q go? Q goes to N. There's only one output for this input. That means this is a function. Okay? So this one is a function. Let's look at another one. This one's going to be a little easier. Let's do P, Q, R, X, Y, Z. P goes to X, Q goes to Y, R goes to Z. Input, output, input, output, input, output. For every one input, there is exactly one output. Can you tell this is a function? Okay, so this guy's good. Let's look at what it looks like when it's not a function. We'll have P and Q for our input values. And here's how you know it's not going to work. I have 3 outputs. So that means that, let's say P goes to X. That's fine. One input, one output. But Q maps to Y and Z. So for this one input value, how many outputs are we looking at? 2 outputs. Problem. Can't happen. Okay, so this one is what we would say not a function. So you can have 2 arrows that converge on one output. Okay, you're going to have cases where 2 different X values have the same Y value. And I think that you've probably seen that on a parabola. Look at this. Have you seen this guy before? Guess what? Both this X value and this X value have the same Y value. Yeah, it's fine. What you cannot have is one X value going 2 different Y values. Okay, that's when you know it's not a function. We'll pick up here tomorrow. Cool?
No homework?
Not yet.
You!
Amazing that this week